Alright guys, let's do our last related rates problem. Here we have the retail price per gallon of gasoline is increasing by 2 cents per week. The demand equation is given by P equals this hot mess, where P is the price per gallon in dollars and X is in millions. At what rate is the revenue changing when 10 million gallons are demanded? Okay, so the first thing you should do almost always with any problem is write down what you're given and what you can decipher from the context of the question. So here are things that we should know. Right away, they're asking about revenue. And revenue is given by this formula down here, which is X times P, right? The number of units sold times the price. Okay, so that should be a refresher from a long time ago. Let's see what the next thing we should know is, or at least remember is. The price is increasing by 2 cents per week. You see how they have that sentence, that phrase, per week right here? It says per week. That means it's changing with time. So we can decipher that sentence. The price is increasing 2 cents per week by the change in price over the change in time, right? Obviously, it's not like the average, but we're taking the derivative. So we have dp over dt equals 0.02. Okay, and this sentence here, I just want to point out that price is a function of x. You see right here, over here, we have things that are in terms of x. But because price is changing with time, that means what you really have is x is a function of t. So as price changes with time, that means x, the demand, is also changing with time. That's why I wrote p of x is actually p of x of t. So it's you almost have a function inside another function. All right, so let's look at the next one. Now we have this guy. This is what we're looking for. We're looking for the rate of change for the revenue over time. And just like in the above statement number 2, we represent that as the change in revenue, dr, over the change in time, dt. And again, this below sentence is just saying the same thing that I said right here, which is revenue is given in terms of x. However, x is changing with time, so that means what we really have is not just r of x, it's r of x of t, which you could write it all in terms of t, but we're just going to keep it like this so we don't have to get crazy. So if you watch my other 4 videos on related rates, you can see like there's just a common pattern going on. Everything here is related with the change of time, so we kind of write all of our variables as a function of time, or the ones that we can at least. Okay, the other thing we should note is that this question is asking us what the rate of change is when we're talking about 10 million gallons are demanded right here, right? And they're telling us that x is in millions. So 10 millions in terms of x would just be 10. So we're trying to find when x equals 10. The other thing we should know that is if x were 10, if we plug 10 into this price formula up here, then the price when we're selling 10 million gallons will be $1.6, that is. So these are all the things you kind of you have to be able to read the question and take out all of these clues from it. These are the 4 most important things, and then we can start addressing the actual question. Okay, so remember what the question is asking. They want us to find dr dt, and we have an equation for r. So what we're going to do is we're going to take this sentence right here, and we're going to take the derivative with respect to t, with respect to time. So here we go. We have our revenue formula right here. So this is r equals x times p, and now I took d dt on both sides. Okay, because I have x times p, I have to use the product rule. So the product rule, if you guys remember, is if x is f and p is g, the product rule says that to take the derivative, let's see, the derivative of a product would be f prime of g plus f times g prime. Hopefully you guys remember that. So that's what I did here. See, I have f times g prime, and then I have, did I say that right? Yeah, and so on and so forth. Okay, so you guys get the idea. We've done this many times. Maybe I should plan that out a little bit better. We're using the product rule here just to go from this step to this step. Okay, and the other thing we can note is that I color coordinated this for you. So the thing in green and the thing in orange and the thing in purple are all going to come in handy right here. We know what x and this guy is and this guy is. So all I did was I took the above information and I filled in everything we know. So x, remember, was 10. The rate of change for price was 0.02, and the price when x was 10 was 1.6. So once I used the product rule, I just filled in everything that I know, and I'm just left with two unknowns, dr dt and then dx dt. So remember, we're solving for dr dt. That means dx dt must be hidden somewhere amongst our knowns. So let's work with the only formula that we're really given besides the revenue formula, and that will be the price formula, right? So we need to find dx dt. We're going to use the price formula to help us out. Because I know what the rate of change for the price is, I can take the derivative of both sides and I'll know what the left-hand side equals. Now this turns into kind of a hot mess, right? Well, not too bad, honestly. The right-hand side, when I take the derivative of it, remember you can always pull out a constant in front of the derivative, so you don't have to worry about that. So then all I'm dealing with is the derivative of this guy right here. And because I don't have a base of x here, I don't have something that looks like this, but I have something, some function of x raised to the 1/2. I'm going to have to use the chain rule. Okay, so in my bottom step, you'll see that I use the chain rule. Actually, this whole thing, I'm missing a 1/10 here. So I forgot to drop down this guy. Okay, so I'm using the chain rule. This brown part right here, that's me dropping this exponent and taking 1 away from it. And then this maroon part is me doing the derivative of the inside function. And then I forgot to multiply by 1/10. So again, I forgot to multiply everything by 1/10. Okay, so now we know again what x equals, and we know what the dp over dt equals, right? We found that out in the very beginning of the question, right here. We know what the green part is, and we know what the orange part is. So I just filled it in. Now we solve for dx dt, and we know that dx dt equals minus 0.32. So this might be the only confusing part that students might get stuck on. They won't know how to find dx dt. So always work with what's given. You know, if you're left with two unknown unknowns, one of them is definitely hidden in the question somewhere. So you got to finagle with your equations and see how to make a dx dt pop up out of somewhere. And we know that price is a function of x, so we know if we take the derivative of the price, there'll be a dx dt popping up somewhere. Okay, so let's just finish this guy then. So this was where we left off before we took this aside. We're just going to fill in what we found for dx dt, and we're left with minus 0.312. So that's the change in revenue over time at that point when x equals 10. Hopefully this makes sense to you guys. I know I'm blowing over it kind of fast, but it's because we've done so many examples of this, and I think you guys are getting the hang of it. At least I think you should. If not, I would highly recommend going back to the first 3 examples because I took a little bit more time on explaining the mindset and the strategy behind what it's like to do all of these related rates questions. I broke it down super simple. So if you haven't watched that or you went through it too quickly, I would recommend going back to it, and then this question will make a lot more sense. Okay guys, see you on the next one.